All right, let's talk about evaluating limits algebraically. So, first thing we'll do is remember, or recall, I guess, our notes. Remember the limit of a continuous function. So, if a function is continuous, right, at a point, so it might not be continuous everywhere, but it's continuous at that point, then the limit is the same thing as the y value at the point. Well, that's wonderful. It means that if it's continuous at the point, all we need to do is find the y value, right? And how do we find y values? Well, take your function and substitute in the x value. So if I had something like this, x squared minus 3x minus 2 is continuous at 2. In fact, it's actually continuous everywhere. Well, that means I don't really have to figure out this limit. I just have to figure out the y value of this function. So substitute in 2, and the limit is negative 6. Again, because the y value is negative 6. And how do we know they're equivalent? Because when we're continuous at that point, the limit at the point is the same thing as the function at that point, right? The y value. All right, so now let's stop this, and you want to do classwork problem 1. All right, so now what happens if it's not continuous at that point, right? It's discontinuous. Well, what can we do? Well, if, and this is a wonderful thing, if you try to evaluate the function at that value and you get a 0 divided by 0, then something cool happens. So let's look at this. So f of x equals, x plus 1 and then x squared plus 3x plus 2. At negative 1, if I were to plug in negative 1, I would get a 0 over 0. And this is very important, right? Well, important. It's actually kind of cool. So what does this mean? It means in order to get a 0, there has to be well, not every time, but in these rational functions, more often than not, there's going to be a factor that produces this 0. There's going to be an x plus 1, which produced this 0. And then there's going to be an x plus 1 times something else that would produce this 0. So what this means is the numerator and denominator are going to have both of these factors. And since they're both going to have the same factors, they're going to be able to be simplified. And you'll see if we factor out x squared plus 3x plus 2, that it does in fact have a factor of x plus 1 times x plus 2. Well, now this can simplify. So if you ever have 0 over 0 as your result for the y, it's a very good bet, especially with these rational functions, that your function can be simplified. All right. So divide these out, you get a 1. You'll get a 1 over x squared. So x plus 1 all over x squared plus 3x plus 2 is the same thing as 1 over x plus 2. Okay, except for the fact that negative 1 doesn't produce a value in this, right? So plug in negative 1, you'll get a 0 over 0, which means it's undefined. Well, if you plug in negative 1 here, it is defined. So you got to tell people, hey, look, you can't plug in negative 1. Even though you can't see it here, initially the function wouldn't allow you to plug in negative 1, so you can't plug it in here either. That's what this is all about, all right? And that's a big deal. So when you simplify your rational functions, you're going to more likely or more often than not take out that problem x. So you got to let people know that, hey, you couldn't, substitute in that at that x value. That's the deal. All right. Okay. So this 1 over x plus 2 is not equivalent to this. 1 over x plus 2 and x cannot equal negative 1 is equivalent to this original f of x. All right. That's our deal. All right. So what are our notes here? If you're going to simplify expressions and limits or simplifying them, whenever you get, right, and 0 divided by 0, when you plug in the x value, right, for the limit, and if you can simplify that limit, right, so the factors will divide out, then you can just simply do the limit by doing substitution. So it's kind of we can't plug in the value because we'll get a 0 in the denominator, but we can simplify it such that we can go back and plug in the value and everything's fine. All right, so let's try this. So here I want to do the limit of x squared minus 1 all over x minus 1. And then specifically at x equals 1, or as x approaches 1. Well, let's try substitution first. Let's put in 1. So, this should be a squared. So 1 squared, let me fix that real fast. That'll be a math type. So let's just go back. All right, so this should be a squared. So 1 squared will still be 1, so it should be 0 divided by 0. And then 0 in the denominator means that this y value is undefined. Right? Well, we have this little kind of, again, shining light that says, look at me, look at me. This 0 divided by 0 is a big deal, right? So that tells me in this rational function, I'm going to try to simplify it. See if they have the same factors in the numerator and denominator of this x minus 1. And you'll see, take x squared minus 1, factor it out. That's x minus 1, x plus 1. You can see the x minus 1s. They did, in fact, have the same factor. And now the limit of this original is the exact same thing as the limit of the simplified. Because remember, a limit is not what it equals at that x value. It's what it approaches. That's why I don't need this comma x cannot equal -1, because a limit doesn't care what you equal at 1. Right? It cares what you approach. So these are equivalent. So then my job is I just need to figure out this limit of x plus 1 as x approaches 1. That's all. So if I were to do that, right? So again, I just noted that, right, when you divide out two things, they divide out to be 1. They don't cancel. They don't disappear. They become a 1. All right, so that's why there's a 1 here. There's a 1 times x plus 1. All right, so now let's figure out this limit. So the initial limit is the exact same thing as a simplified limit. So let's do the simplified limit. Oh, the simplified limit, I'm going to do direct substitution. So I'll get 1 plus 1. And then the limit of this rational function where I couldn't plug in 1 is the same as the limit of this simplified function where I can, and they both have a value of 2. Again, and then what does that mean? It means as you approach x equals 1, so as you approach that 1, this function, x squared minus 1 over x minus 1, will approach y equals 2. Or just approach y equals 2. Is that all right? That's our deal. Okay, so you want to stop? It's actually the end of the video, so do class work problem number 2.